Good morning, everybody. Welcome back to lecture number 9. Last time we talked about the magnetic fields are the fundamental mechanism in which energy is converted from one form to another in motors, generators, and transformer. And we said we'll begin with transformer. Why?
Stationary.
Because they are stationary, but motors and generators,
Rotating.
they are moving, so we'll defer them. Even though in reality you start with generators and transformers, so let's flip them, okay? Electric machines are an application of 340, tamam? One of the applications, not all of the applications. We talked about rotational motion, okay? And what did we say? How many speeds we have? 3 different speeds. Angular, radians per second, revolution per second, revolution per minute. Which one is more practical for cars?
Per minute.
RPMs. And the acceleration is how fast that omega changes with respect to time. Then we talked about the torque. Same in real life. If you want to apply a torque, you need to have some sort of angle. We call it torque angle. Once you push the motor, it will spin. Okay? If you push it perpendicularly, the torque angle is 90 degrees perpendicular, so the torque is 0. Right hand rule. There is right hand rules. You do it with the palm. For us, 360, the right hand rule is with that, okay? Because we have 2 vectors. If you have 3 vectors, you have to do the palm. If you have 2 vectors, you have to do this, okay? So you have a coil, and it has current, a conductor, most cable. So for a cable that has an AC current going through it, what is the magnetic field? The magnetic field is gonna form using making circles that are in the direction of your fingers. Your thumb is the direction of the conductor. What if I bring a magnet and I loop around it a cable and I put current through this cable? The magnetic field is going this way. So the current that would produce this magnetic field has to go this way, entering the cable, leaving, entering, leaving, entering, leaving. It's easy, okay? Magnetic field strength can be increased by making the wire into a coil. Magnetic field strength can be increased by increasing number of turns or the actual current. So the magnetic field B, if you push more current, we expect more magnetic field. Or if you have more coils, more turns, we expect to have more of the magnetic field. Think about just 1 turn versus 100 turns. Which one has a bigger B? Of course, the more turns. Not only that, there is another law. So this is Ampere's right-hand rule. There is Ampere's law, which basically is telling you for a conductor that carries current, if you do the closed path integration, Math 201, and you know I'm not a good mathematician, so if you do the closed integral of the path of the current, so if you enclose that current, all the current, the magnetic field intensity, okay, is produced where the net current and the differential length along the path of integration. Basically, along the path of integration, if I have a current, I would have a magnetic field intensity. Along the path, L. So if I get this length of the cable and I do closed integration, I would have a magnetic field intensity. If I take the whole cable, I would have another magnetic field intensity. So magnetic field intensity, it has to do with the length of the conductor. This slide does not explain the Ampere's law in details, but it gives you an indication that to get the H, you also need to increase the net current. What's the net current? It's the current that moves through the conductor if you push more current. Now if you have coils, if you increase coils, you increase the current, the net current. If you increase the net current along the path, you increase flux, magnetic field intensity. المجال المغناطيسي.
الكلوز باث حق الانتجرال هو السيرفيس حيكون؟
No, with the length of the conductor. DL, 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 DL. You take every current, you close path integral, so you have to integrate all across the length, okay? Across the length, and you calculate every incremental length with every H. If you do that for closed path, you would notice it's equal to the net current. That's what it tells you.
بس كيف حيكون كلوز سيرفيس؟ حتكون كلوز انتجرال ولا؟
Yeah, you can integrate to a surface with respect to length, math 201. Sometimes, do you remember in math 201 you have, I forgot, long time ago. Something like that, you do something like that and then they put the dx. So this is like dx. Then you put dy. Stupid, okay? Get it? Basically think of dl as dx across the surface. You can do d theta, spherical coordinate. You remember that? You can do cylindrical. Yeah, you can do whatever. It's math. This is EE, so don't ask me. Okay? I told you. Never ask me questions in math, okay? But the key, differential length, magnetic field intensity, if you do closed path integration, enclosed, it's equal to the net current. So technically you have to do multiplication of magnetic field intensity, index sensory intensity, times the differential length, you get magnetic field. It's beyond the scope of this course. How many magnetic flux? Magnetic flux, they are the lines that form a closed path next to each other. If the lines are close, magnetic flux is high. If the lines are more spaced, magnetic flux is smaller. فحدوة الفرس هذا عندنا from north to south. Across the magnet here, the 1, 2, 3 in the middle lines, the magnetic flux is big. Outer flux lines are apart, so magnetic flux is smaller. For the current, closer to the conductor, the lines are going to be closer. Further away, it's going to be smaller. لو حطيت بوصلة هنا، هذه بوصلة north with south, the north would point to the direction of the vector B. Magnetic flux B. If you have this case, which is a more complicated case than these two, you have a magnet and you wrap that magnet with a coil and you put a current through the coil. So the magnet itself has north and south, and it usually has lines. As long as you're walking through the lines, you're walking through the magnet, there's lines. But the moment you leave it, they want to close the path. So half of the lines would go this way, half of the lines would go that way. And the further away, they're going to be more spaced until they meet again and become close to each other. Not only that, because the coil, كل واحدة من الكوندكتور اللي طالع is like this, has its own circuit. So it's a mess. 1, 2, 3, 4, 5, 6, 7. It's a mess. Okay? Get it?
Yes.
So this is iron core, then you will have a north and south. Now, magnetic flux, the first quantity is called sigma. So what is sigma? Measured in what? Weber. Magnetic flux without the word density اللي هو التدفق المغناطيسي أو المجال مو مجال التدفق المغناطيسي. It's measured in Weber, and it is what? Flux lines leave the north, entering the south. I don't care about north or south because we deal with AC. So the north would become south every time the AC changes its signal. but at an instant of time from north to south. لو حطينا بوصلة, the direction of the north is the direction of the vector B. Okay? Quantity number 2, magnetic flux density, which is nothing but divided by the cross-sectional area, which is Weber per meter square, which is Tesla. So B is Tesla. Say with me, B is Tesla. You know why they named the unit Tesla? Because Tesla failed in the society. So this is to honor him, they named the unit Weber per meter square. It's not only that, if the flux goes perpendicular, the equation B or B equal phi over A is true. But if you have, for example, B that is not constant, for example, changes, the magnetic flux changes with real time, like MRI. تعرفون الMRI في المستشفى؟ What it does, it rotates, صح؟ فit changes the magnetic field عشان to do magnetic imaging. Or if the flux lines are not perpendicular, if they come at an angle, you can't use this formula. For the purpose of this course, we're going to make these two assumptions. Okay, so this is magnetic flux, this is magnetic flux density. التدفق المغناطيسي, شدة التدفق المغناطيسي. We had H, what was H? Magnetic field intensity. اللي هي شدة المجال المغناطيسي. في فرق بين المجال المغناطيسي والتدفق المغناطيسي، زي ما في فرق بين المجال الكهربائي والكرنت. Get it? So magnetic field intensity is not practical. What's practical is B. B is in Tesla, okay? Not only that, we have another quantity called the MMF, magnetomotive force, MMF. It has a symbol of F like that, okay? It's not that F actually, it's F with certain changes. I will update the slides. But the F here is MMF, magnetomotive force. It is basically telling you that it's the ability of a coil to produce flux. So I brought stuff. What is this? مغناطيس فدوة الفرس؟ غلط. No. Life is not rosy like that. No. This is steel. So if you look at this steel, YouTube, if you look at this steel, you see it's laminated. Okay? It is what? Laminated, شرايح. Lamination is to increase the permeability of magnetic field. So this is just steel. It's not a magnet. Now why do we have it with that? Because I can insert stuff inside. What I'm telling you is, this is what? Steel. Okay, what is this? Coils. They are insulated عشان ما تخرب. So inside this are coils. Copper coils. Made of what? وهذا made of? What are those? Terminals. So you can see it's 400 turns, يعني 400 لفة, with 1.1 mm. يعني each of the conductor is 1.18 millimeter diameter. And it tells you that this is what? An inductor, not resistor. But even though they put the symbol resistor, but these things are old. They were smart in the old days. So they do not even tell you what is inductance. You have to calculate it yourself. Get it? So this is a problem. Is sometimes you want to do, okay, I have this. What is the inductance? Tell me the inductance. No, you have to measure it or calculate it. He's telling you what is the wire. He even tell you what's the name of the wire. He's telling you a number of turns. You have to calculate it. So this is what? The ability of these coils to produce flux is called, and it's related to N. What is N here? 400. What is I? Whatever we apply, I don't know. Maybe we apply 110 RMS, which is 110 times square root of 2 peak. So it would change. But if you, let's get the RMS because we love RMS. What will happen here is to increase the ability to produce flux, increase number of turns or increase the current. Again, there is with that steel, it has what we call reluctance. What is reluctance? Reluctance is a mumana. How much this steel would not allow flux to go. So, what is a number that tells me this steel is a good conductor for magnet or less reluctant of magnetic flux? So, the MMF, and the way they do it is we put it this way, and then we close this.
دكتور المنع هي resistor.
No, reluctance. No, minor mush resistor. R is not resistor. There is a no. We will introduce R later. It is not resistance. So, whatever. I tried to do it for the other class, but I forgot how to do it. But I think it's like that. So you do it this way. Now, if you apply the current entering here, let's say the coil is this way. Where's the direction of the flux? Here. Up. بعدين هنا. To your right. هنا. تحت. هنا. To your left. Your left, not my left. Okay? So if you have small reluctance steel, you're going to have more flux. If you have more coils, more flux. If you have bigger current, more flux. But again, we'll talk later about you can't have infinity current because you will burn the coil, you will damage everything. Okay? So MMF magnetic circuit is similar to voltage. MMF causes the flux to flow. فالفلux كأنه current والMMF كأنه voltage. والreluctance كأنها it's not the same. It's not the same. This is our thing, okay? What's the polarity? If we put this, we put that, it goes this way. Where is the plus sign? Well, it's here on the top. Why? Because it's where the flux starts flowing. So the flux starts flowing here, right-hand rule. So you have to use right-hand rule every time you put the voltage source. Is this a voltage source? Wrong. That's an MMF source. So what is the MMF source? Is this thing when it has current. Get it? Please, these are important concepts, okay? I'm not gonna make the trivial things more trivial, but it is what it is. So the polarity is what? Right-hand rule, the current enters here. The polarity is where the flux originates. Plus, what is this? Flux. Measured in Weber. What is this? MMF. Measured in amps per turns. So what did we say? It's Ni over reluctance. Forget it. No, ما في R. It's Ni. So its unit is what? Amps times turns, or AT. هذا الفلكس. الفلكس divide by that. Okay, هذا Ohm's law. Now, get it?
دكتور احيانا الفلكس ما نقدر نقول انه هو نفس الكرنت.
No.
بس نفس الفكره.
It's not the same quantity. زي ما الميكانيكال.
بس نفس الفكره.
No, it's analogous. Analogous يعني قياسا عليه وليس نفس الشيء. It's not the same. Trust me. It's not the same. It's wrong. It's like saying voltage is same as MMF. It's saying that they are not the same. MMF is magnetomotive force. Now, magnetic field intensity, شدة المجال المغناطيسي, which is different than magnetic flux density. Flux and field, they are not the same. Similar to the electric field
Current.
or current, they are not the same. But they are somehow related. It's the intensity per unit length. The key word about the H is length. The formula is MMF over length. So the H is F over LC. What is LC? I put my thing back. I think this is damaged. Is the length, so flux goes through the rectangle, okay? Is the flux 50, this is maybe 10 plus 8 plus 10 plus 8?
No.
Is it 6 plus 4 plus 6 plus 4? Wrong. It is the length between المسامير الأربعة دول. In the middle. هذا نسميه المين length. مرسوم عليه خط. Okay? In the board, you put a مسمار هنا وتحط مسمار في النص، مسمار في النص، مسمار في النص, you measure the distance. Why? Because some of the flux would go here, some of the flux would go here. So you take the average length. So maybe it is, I don't know, 7 plus 9 plus 7 plus 9, something like that. You measure it.
يكون اللينك اللي جوا الكويل.
No, the length of the core. إيش معنى core؟
حديد.
حديد. Core is حديد.
حتى من برا الكويل.
هذا مو حديد، هذا كبر نحاس.
لا اللي يكون اللي برا يعني في الكويل.
Yeah, because when you constantly apply AC, if you apply DC يا مشعبي, what will happen?
ما يشتغل شيء.
Why?
اندكتر كيف
Because inductor has J omega L. If omega is 0, Z will be 0. Then it will be like short circuit. Is it smart to apply current in a short circuit? DC battery in a short circuit? You're draining your battery. So the flux would go and close its path here. Because it closes its path, you have to measure the length of the whole core, not the length of the coil. Yeah, the intensity here might be more, but again, the steel is like copper. Steel for magnetic flux is like copper for electricity. Can the electricity escape the air?
No.
No. But for this steel, some of it would leak. And that's what we call later, we're going to call it later leakage. يعني sometimes some of the designs, you can see here we have a little bit of air gap. Air gap يعني مسافة. Maybe here it's not purely rectangle, maybe there is an angle. فبيصير تسرب للمجال المغناطيسي على الزوايا مثلا. Maybe here, maybe if there is a big magnet, a big machine here, it will get some of the magnetic flux. But in general, the steel would route the magnetic flux to go through it. زي ما الكبر would guide الإلكترونات إنها تمشي عليه. Reluctance. The symbol of reluctance is this R. First, what's the unit of H? Amp turns per meter. So it's the MMF per length. What is after that? Reluctance. We do it this way. R and put lines here, put lines here. Okay? Or you can do R, put another line, color it, and then put another line, color it. I don't care if you do it this way. To indicate this is not a resistance. An MMF is not a force. That's why MMF we do it F this way. Not a force. Again, what's the equation? The effective length over mu times A. What is the effective length? Effective length دائما when I tell you effective length تذكروا هذه الرسمة اللي رسمتها على الكور. which I think the EE labs will give me a hard time when I give it back to them. So we need to clean it. Okay? That's the effective length. It's not the outer rectangle, not the inner rectangle. طبعا وين مجال التريكات في الاختبارات؟ He messes with the effective length. What is it? Permeability. Permeability is the ability to pass a magnetic flux through the core. Now, for non-magnetic material, there is a relationship linear between flux density B and magnetizing current I. They have constant permeability. The air has a permeability. It allows magnetic flux to go through, but it doesn't route it. Even if you apply more current here, we would have a magnetic flux, but it will not go back. It will spread. So it doesn't permit it to go into the closed path, the air. So for the same amount of current, if I put it in a steel, I would get more B. Get it? So if I apply here I, magnetic flux density, maybe it will be 0.001 Tesla. If I put the steel here, for the same current, I would have maybe 3 Tesla. Get it?
Yes.
So permeability for magnetic material, for the same amount of current, we have much larger B. It means it's not linear. The relationship we will have later, saturation, we'll talk about it later. But in air, the permeability, it tells you how much of a number of how much of the material is allowing magnetic flux to go through it in a uniform path. For air, it's 4 pi 10 to minus 7. Do you want this in the cheat sheet?
Go. It is the calculator.
It's in the calculator in the back. It says in the calculator. But maybe, as long as the cheat sheet is not leaked, which may not be leaked because we have. I don't know. I have to talk to university to see if we are allowed to have cheat sheet. Okay. Now, if we want to have a cheat sheet, definitely we'll include this because you can't memorize. Okay. Now, what is mu? Mu is mu naught times mu r. What is mu r? Relative permeability. Mu naught حقت الأرض. So you're measuring relatively with the air. There are numbers. For example, the steel has some of the good steel, expensive steel, 6,000. Cheap steel, 2,000. So 2,000, what does it mean? It's 2,000 better than the air or a vacuum. 6,000 better than the air. So if you think of it, if you have a copper and 90% copper or 60% copper in terms of conduct losses, etc. Of course, a better accuracy. So the permeability of iron is higher than the air. A major portion of the flux in the configuration remains inside the core. Core is steel. Core is steel, okay? And instead of traveling outside. But if it's air, it will travel. If it's water, travel. If it's a human, travel. If it's copper, I don't know. Research it, okay? We have also a leakage flux. Leakage flux, as I told you, is, the flux would go here, but some of it would just jump around there. That's leakage. Jump around. Because it jumped around, it would have been more ideal if it went through the rectangular angle, the 90 درجة. But some of it would leak, some of it would go this way, some of it would go that way, due to non-idealities. Check the camera, please. It's in 13. Yeah, please. We don't want to repeat the lecture. So where do you get in mu r? From a data sheet. I don't know if mu r is written here. I doubt. because they tell you the grade. Again, in the old days, you have to go do it yourself. The grade. حاطين grade. طبعا the grade changes. But this is the summary table, okay? This is all the equations and how you relate them together. So if you can see flux density is BA, but also it's F over R, Ni over R. R is resistance, ماشي عبي. R is resistance?
No.
No.
No, it's reluctance. You know why I called it. For two reasons. Now, what is H? Is F over LC, not over R. Okay? Don't confuse yourself. What is magnetic flux density? Is BA or mu times H. This is a new formula. Many students forget about it. Or the MMF, you can relate it directly. Or reluctance, which is L over mu A. Or permeability, which is mu naught times mu R. Not only that, this table tells you that MMF, when you draw the magnetic circuit, MMF is like the voltage source. Like, not the same. The current is like flux. Resistance is like reluctance. You can combine the reluctance in series or parallel. Your EE no need to explain series or parallel. مصيبة if you don't know how to add series and parallel, okay? It is the same way of adding. In series, they add together.
I know it. Until now, we are in the same reductance like the resistance.
Let's see. We'll try to solve an example in a second and see how things will work. KCL as KVL are applied. Basically, in the magnetic circuit, you can say, for example, minus V. Okay, I'm going to use my method. Voltage rise plus V minus IR equals 0. MMF, is it MMF rise? It's plus F minus 5 times R. Or your method is minus, because it's a minus, plus, and I'm not going to use this. Okay? You can use it, but I don't like it. Okay? I'm with the other school. We want to challenge the system. Okay? So KCL is summation of flux at a node. Node can be, this is a node. So flux coming in equal flux out. Plus leakage. Don't forget the leakage. The KVL is if you put this is an F, you resemble everything here as R. Now, here's a figure I want to show you. What if I have a steel that has infinite mu? What is its reluctance? 0. 1 over infinity is 0.
Okay.
Use the formula. L over mu A. If mu is infinity. So everything here is a short circuit. I have air gap. What is the air gap? No, مو اللي في النص. The air gap has to be in the path of the flux. This is an air gap. هذه صغيرة. تسكر, but sometimes they have a design this way, they have a design that way. Sometimes they have a design this way. Sometimes they have a design that way. So what is the air gap if you have a design this way? The flux would go here. This is the air gap. This is not air gap. And هذه is not the direction of the flux path. هذه in the direction of the flux path. So air gap هي الفراغات اللي في الفلكس path. What is the air gap?
فراغات اللي في الفلكس.
الفراغات اللي في الفلكس path. So what is the air gap here? المثلث. Doesn't include outside. So what is the air gap here? What is the air gap here? نص المربع. فهي الفراغات اللي في الفلكس path.
This is called
air gap, فراغ هوائي. Air gap. You have to measure it, and again you apply the formula. L over mu. What is mu? Mu naught, because mu r is 1 في الarea. Times the cross-sectional area. Cross-sectional area of triangle, of a circle. Trick in the exam. What is the area of the circle? Pi r square. What is the area of a triangle? نصف القاعدة في ارتفاع. What is the area of توازي الأضلاع? You don't know. A plus. Okay? Figure it out. I don't know. It's BA. HA. What if I bring you a chord that looks like that? Please, okay? And it exists actually. It's called, it exists. Some of the magnet stuff, they tilt them a little bit.
طب انتوا خطير انه يكون في جاب.
No, magnetic flux is a flux. مغناطيس is not gonna harm. You design it for a reason.
يعني ايش الريزون هذا اللي يخليك؟
There are many reasons. One of the reasons is if you change the reluctance, you can change the flux. So you can control how much the flux. If you control how much the flux, you can have for example, electric motor, you can have certain speeds at certain values of I. You can have any design you want. So reluctance 1 and reluctance 2 are for the air gap. If this is not infinity, I need to account for reluctance for every part of the core. We'll talk about this in the next lecture. For now, R1 and R2 are for the air gap. Fringing effect. You got it now, fringing? Fringing effect. هي يقول لك إنه flux lines sometimes they leave and come back. And this implies the flux density here is not equal to here. So fringing effect is spreading of flux in the air gap. It is bad since it increases the effective cross-sectional area of the air gap. Example. I want volunteers who are willing to appear in the video. Last time you volunteered. Did you volunteer last time? Come. Another volunteer here. Please. Erase the board and I'm going to ask you questions. Task number 1, tell me what is given with symbols. What is task number 1? Any garam Task number 1, tell me what are the quantities given. For example, what is 16 centimeters square? Area. So put area equals 16. Should we put centimeter there? We should put meter, SI units.
Okay.
Please list all the given things. So 16 centimeter is wrong. It has to be 16 convert 16 to meter تربيع. Convert L. List all the given parameters. It's easy. Line number 1. Is there any given parameter?
No.
Line number 2. What is the information? All the sides of this core are uniform width. What does it mean? Means the cross-sectional area is uniform.
Yeah.
So what is the cross-sectional area? Write it as math. How to convert from centimeter تربيع to meter تربيع? That is wrong. That is grade 4 mistake. معلش, I'm sorry, but convert it. Wrong? Probably right, but no, it is centimeter times centimeter. Here it's 10 to minus 2. Here 10 to minus 2. So it is 10 to minus 4. So don't make this mistake. How about you? Erase and... Okay. No. We gave it symbol A.
Okay. A equals.
Put the units. We have 4 minutes. You have to finish quickly. L. What is LC? Effective length 40 centimeters. Quickly. LC 40.
What is C equals 1.4.
No. Yeah. 0.4. What's the third quantity?
Coil.
350 turn. What was the symbol?
N equals
N.
350 plus.
اللي هي هنا كم كانت؟ 400. Turns, the unit is turns.
Active terms can.
You have to write the unit turns. Yeah,
Turns it's small n, yes.
it doesn't matter. Yeah, capital N. What's the unit? Turns. No, this, what is this? No, not N. 360
350.
turns. 350.
It's n.
350. Yeah, N equals 350 turns. Continue. What is the relative permeability? Mu R. 50,000. So what is the mu? No, this is the mu R. Equal mu.
لها وحدة.
It has a unit, but it's complicated.
Okay.
I'm not going to write it. The unit of permeability is Henry per meter. No, relative permeability is unitless. What is the mu? 50 times mu naught. 50,000 mu naught.
Okay.
This is mu R. This is the mu R, small r. What is the mu? Mu is mu naught times mu R. هذه ما لها وحدة، هذه لها وحدة. So just write it as a mu naught because mu naught is a number.
يعني زي كذا ولا أكثر؟
No, this is mu R is 50,000. Mu equal mu R times mu naught.
Okay.
So mu equal mu R times mu naught. So it's 50,000 mu naught. And it has a unit of Henry per meter. Quick. Now, last quantity. Magnetic flux density of 1.5 Tesla. What is Tesla?
B.
B.
ويبر over
B.
Yeah, but we love Tesla. Okay? Tesla is better. No, T is enough. Don't write the word Tesla. So, what is the flux? What is the flux? The flux is, what is the symbol of the flux?
الفاي.
Phi. What is the equation of phi? Go to the table. What is the equation of phi? You have B, you have A. You have B times A. Okay? Calculate.
Only for the division.
Calculate. Please, finish the exercise. We don't have time. 1 minute left.
طيب.
What is
1.5
times 16 times 2 to minus 4? Don't write everything. اضرب على طول. No, you already did the multiplication. What's the answer?
هذه
No, that's wrong.
2.4 10
2.4 milliweber. It's wrong. 2.4 milliweber. Now, to get the current, you have to get the reluctance. خلاص, you can have a seat. So, what is the lesson learned? You have to list W small b. Study this lecture today. It is hard. Okay? The second part, I want to get the current in the coil. How to get the current in the coil? I have to get the reluctance, which is LC or E, effective. You can call it E or C, over mu times A. And then you get the MMF, which is phi, 2.4 milli times R. You should get this number. And to get the current is MMF over number of turns. What's the unit of the current? So next class, we will start the class by this activity. And you will do it here in class. Okay? Any question? You're free to go.